Hi everyone, my next lesson is going to be on long division with polynomials. At the end of our last lesson we started exploring what factors were and what remainders were, and we looked at some problems that involve polynomials and factors and remainders. And we got to a point where we were looking at what you would multiply x plus 1 by to get x cubed plus 6x squared plus 9x plus 4. Now in this case I've got a plus 6 on the end because I've set it up so that I'm going to get a remainder, because that's part of what I want to discuss today. So before I do this problem, what I'm going to consider is, or what I would like you to do, is to think back to when you were in primary school and you first started doing division, and the problems that your teachers gave you were pretty simple ones, and you drew some diagrams to break a number up into different parts. And then eventually, as you went down that division road, your teacher gave you problems that become trickier, and they looked a little bit like this. And we had something like, I'll just make that a little bit longer, 1,524, how many 13s? And the first way that they taught you to do this, or one of the ways that they would have taught you to do this, was using a process called long division. So let's revisit what that long division looks like in this problem. So the first thing I would do is I would take the 1 here and I would say, how many times does 13 go into 1? And we all know, well, that doesn't go in there any times nicely. Doesn't work. So I immediately jump to the next stage and I say, well, how many times does 13 go into 15? And we know that 13 goes into 15 one time. And there's going to be a remainder of 2. We're year 11 students, and we know that there's going to be a remainder of 2, but I'm going to pretend that I didn't know that straight away in my head. And our long division process is, I then said, well, let's work out the remainder. And my first step to work out the remainder is I'm going to take the 1 and I'm going to multiply it by 13, which gives me 1 times 13 is 13. And then I subtract that 13 from the 15 that I had to start with. So 15 subtract 13, I get the answer of 2. So my remainder in that first part of the problem was 2. And the next part, it was I would bring down the 2 from the tens column here and make that 22. All right, so I worked out that from the first part there was a remainder of 2, and then I use it with the 2 tens to do the next part of the problem. And now I say, what's 22? How many 13s? Okay, well, I know that 13 goes into 22 one time. And I could work out the remainder in my head because we're year 11s, but let's pretend that I couldn't. I'm going to now work out the remainder using an algorithm, and my algorithm is I'm going to take this 1 and I'm going to multiply it by the 13, and that will give me the number 13. 1 times 13 is 13, and then I do 22 subtract 13. So 2 subtract 3 I can't do, so I steal from the 2 tens. I make that 1 10 and 12 units. 12 units take 3 is 9. 1 10 take 1 10 is 0. So I have a remainder of 9. Nice. Now I'm going to bring down the 4 units from the top. And my next step is to say, okay, how many times does 13 go into 94? And if you get this right and you work out in your head, okay, I think it's about 7 times. I'm not quite sure that I've done the multiplication right. Let's actually write that down. So I'm going to put in a 7. I think it goes in there 7 times. Work out the remainder. I take the 7 and I multiply that by 13. So 7 times 13. 7 times 10 is 70. 7 times 3 is 21. 70 and 21 makes 91. So I need to put a 91 in here, and I'm going to subtract them. 94 subtract 91 equals 3. So this value down the very bottom became my remainder. Now your maths teachers in primary school might have explained long division slightly different to that. There might have been some tricks and tips that they did along the way, but this version of long division is what I'm going to use to start to solve my polynomial division problem. And so what I want to move on to now is exactly the same set of steps, except we're going to do it with algebra. So the very first thing I need to do is I need to rewrite this expression in my long division format. So I need x cubed plus 6x squared plus 9x plus 6 divided by x plus 1. Alright, so the first thing I'm going to do is I'm going to start with the x cubed. And I'm going to divide x cubed by x. I'm just going to ignore the plus 1 part. It kind of is confusing me. I don't really know what to do with it. How does that fit in there? But I do know that x cubed divided by x is equal to x squared. So x cubed divided by x is x squared. Let me just write that down. X cubed divided by x equals x squared. So that's a nice little easy part to start. Now let's work out the remainder to move on to the next part. So I'm going to take the x squared and I'm going to multiply it by this whole expression. So x squared times x is x cubed, and x squared times 1 is 1x squared. And I'll write the 1 in there to make it a little bit easier. Now my next step, to work out the remainder from this first part, I have to subtract them. And what should happen here every time is your first terms will cancel out. If they don't cancel out, then my problem's not getting simpler, and I've maybe done something a little inefficient. But then I now do the second part, which is 6x squared subtract 1x squared, and that equals 5x squared. All right, so we move on to the next step now. Let's do 5x squared. How many x plus 1s? Now I can't forget as well, I also need to bring down the 9x from the top. So 5x squared, how many x plus 1s? Now I'm just going to work with the x part first, and I'm going to do 5x squared, how many x's? So I'm going to do 5x squared, how many x's? And the answers to that is equal to 5x. So my 5x, I'm going to put up here, plus 5x. All right, now I'm going to take the 5x and I'm going to multiply it by this whole expression, x plus 1. So if I do 5x times x, I get 5x squared. And then 5x times positive 1, that's positive 5x. And to work out the remainder with what I've got, I need to subtract these two parts. And again, these first bits should cancel out. If they don't, you've worked in an inefficient way. So go back a step and work out what the numbers should be so they do cancel each other out. And then 9x subtract 5x. That gives me the answer of 4x. Bring down the 6. All right, now I'm cooking along. I've got down to a linear expression and I need to, oops, wrong button there. I've got down to a linear expression. I now need to do 4x plus 6 divided by x plus 1. So I only focus on the first terms here. I'm going to do the 4x divided by x, which gives me just 4. So I put down the plus 4 in my expression up the top. And then finally, I need to multiply this 4 by the whole expression x plus 1. So if I go 4 times x is 4x, and 4 times 1 is positive 4, and I'm going to subtract these. Alright, my 4x's cancel out. Good, that's what I wanted to happen. And then 6 take away 4 is just equal to 2. So my expression here, I have my whole problem solved, and this plus 2 at the end, x doesn't go into 2. X doesn't go into 2, so this is the remainder. Okay? So I have a remainder of 2, and the actual answer, or what we call the quotient is the x squared plus 5x plus 4. So what I can write is, I can say that x, I've got to remember the first question now. Oops, sorry. My original problem was x cubed plus 6, x squared plus 9x plus 6, and I wanted to divide that by x plus 1, and my answer to that problem is whatever I got in my quotient. So it was x squared plus 5x plus 4 with a remainder of 2. Now, I could write this with just a little bit more detail. Now, probably not really required at the year 11 level, but this is going to help you later on in higher level maths. So I've got my answer of x squared plus 5x plus 4, and that remainder of 2, that 2 still needs to be divided by x plus 1. So I can write that as a fraction at the end. And this can help with much more complicated graphing that moves beyond polynomials, and also a process called integration that we'll get to later in the year. And that's the process of long division. It needs some practice. You will make mistakes along the way, and that's okay. Don't give up, keep working on it, and you'll get more efficient and quicker at these problems.